Welcome to this presentation on the mathematician-engineer cycle, a way to plan that guarantees the process standard of connections being a part of your lesson. To begin, we will revisit the traffic jam activity. Recall that we started by playing the traffic jam game of switching cubes on sides. After several rounds of transcribing slides and jumps, we looked for patterns and tried to determine a function. This led to an abstraction of a formula so that, given the number of people on a side, we could calculate the number of moves it takes to switch locations. Then we looked back to the game to figure out where the n squared and the 2n were embedded. This is the mathematician-engineer cycle. Starting with an experience or experiences, we try to generalize what we see to make an abstraction. This is what a mathematician does. If we start with an abstraction, like a formula, and apply it to a situation, then that is what an engineer does. Now, for many teachers, they only present the lower half of the cycle. For instance, giving students a formula for the area of a trapezoid and then asking students to calculate the measure for a page filled with figures. This results in students simply learning to plug in the numbers. Of course, some teachers do focus on the upper half of the cycle. They may have students look at data and try to find a trend or prediction. Often, this leads to the, "Phew! We found the pattern. Now we're done." Neither of these situations provides a robust view of mathematics. We need both the upper and lower halves to make a complete connection. To truly make sense and develop deep meaning, students need to generalize like a mathematician, and they need to apply like an engineer. And now, we'll take a brief intermission. Let's look at another activity, this one involving concepts from geometry and trigonometry. To start, cut out the 6 circles that were provided in the "What is a radian" attachment. For each circle, you will need to find its center. Use a ruler to draw a radius, then use a pipe cleaner, yarn, or string to measure the radius. Carefully transfer that measure onto an arc of the circle. Note, the dots on these slides are exaggerated. You should use small marks and try to be as precise as possible. Next, mark the end of the arc and draw a second radius. Finally, use scissors to cut out the wedge that you've created. Once you have a wedge from each of the 6 circles, you will need to compare and contrast among the entire collection. Now let's use all the radians at the same time. Start by drawing a large Cartesian coordinate system centered on a blank sheet of paper. Next, place one of your wedges in the first quadrant, with one of its straight edges along the positive x-axis, and the arc sweeping counterclockwise. You will need to place a second wedge, aligning this new wedge counterclockwise against the first wedge. Continue placing all 6 wedges counterclockwise around the Cartesian coordinate system. Of course, we'll end with a joke. What is the difference between a mathematician and an engineer? What's the difference between a mathematician and an engineer? One trains the mind, the other minds the train.